So we are into solving linear equations, just kind of continuing what we were doing last class period. And so I just kind of posted just kind of a review right here, just to kind of read over, but a linear equation that could be written in the form of a times x plus b equals 0. The reason we have to say that a can't be 0, that coefficient in front of that x was 0, well, 0 times anything is 0, and that was no longer be linear. Then we went and we started solving linear equations. And so there's a process when you're solving equations. First, you could look at what type of equation it is. And if it's linear, it kind of should clue you in how to go about solving it. Usually I do list any restrictions on any variables. So remember, we had sometimes variables in the denominator and we couldn't have values which set that denominator equals 0. And so we had to exclude those. If necessary, you're going to clear the equation of fractions by multiplying both sides by the least common multiple, or I could say least common denominator of the denominators of all the fractions. So remove all fractions and simplify, collect all terms containing the variables on one side and the remaining terms, so terms without the variables, letters on the other side, and then you're going to solve. But you also have to be careful and check your solutions, especially if you made any restrictions. It doesn't hurt to check solutions in general, just if you have time to see that it's correct. Okay, so I pulled up another example. And so here's an example where looking at it, it's a rational equation because you have variables in the denominator. But once we start solving this, this is going to get into linear in form. If you have variables in the denominator, this is where you have to be careful and you have to exclude those values which set the denominator equals 0, and that can't be part of our solution at the end. And so in this case, y plus 3 can never be 0. And so y plus 3 is equal to 0 when y is equal to -3. And if you don't see that, then you're going to have to set that y plus 3 equal to 0 and go about solving that for y. So same thing here, y minus 4, we're set that equal to 0. Well, that's when y is 4. So y can't be 4. And y plus 6 can't be 0. So that would be when y is -6. Okay, so those are our restrictions. So next thing you want to do is find the least common denominator of all these fractions. None of these are common factors. They're all linear factors. And so the LCD is going to be all of those denominators multiplied together. So y plus 3, all times y minus 4, all times y plus 6. The whole point of multiplying both sides of our equation by that LCD is so that we can clear our fractions. If this didn't have an equal sign in here, maybe this was a plus or something, we can't clear fractions. We would have to get a common denominator and just simplify. So you have to be able to identify the difference between solving an equation and working and simplifying an expression. Okay, so we're going to multiply both sides of our equation by this y plus 3, y minus 4, y plus 6. And I'm going to just do that and put it next to each grouping right now while I write it out. Okay. Okay, so I have this 2 times y, or 2 over y plus 3 all times our LCD, plus I have our LCD all times 3 all over y minus 4 is equal to this 5 all over y plus 6. So things start canceling out, which we wanted. So y plus 3 in the numerator here and the denominator cancel. Over here, y minus 4s cancel. And here, y plus 6 cancels. So let's kind of distribute here and combine like terms. And so if we did that, we would get y times y, which is y squared. We get y times positive 6. So that would be a 6y, and this is a negative 4 times y minus a 4y. So 6y minus 4y, that would give us a plus 2y right here. Negative 4 times 6, so minus 24. All times still this 2 out front. Plus, so I'm just gonna maybe move this 3 in front so I have the purple on. And let's distribute, let's multiply this y plus 3 times the y plus 6. So y times y, this would give us y squared. Y times positive 6 is 6y plus a 3y, so that would give us a 9y here. And a 3 times 6, so plus 18. Equals. And so same idea here, we have to distribute y squared plus 3 times y minus 4. So y times y is y squared. Y times negative 4 is negative 4y, but plus this 3y would give us just a negative y. And 3 times negative 4 is negative 12. Okay, so we've cleared our fractions. We have a lot of simplifying to do on one side of the equation, so we need to distribute and simplify. So let's distribute that 2 first to every term in the first parentheses. So 2 times y squared is 2y squared, plus 2 times 2y is 4y, minus 2 times 24 is 48, plus, so let's distribute this 3. So 3 times y squared is 3y squared. 3 times 9y, this gives us 27y. And 3 times 18. I got 3 times 8, well that's 24. Carrying my little 2, 3 times 1 is 3 plus 2, so that's 54. Equals, now distribute 5. So 5 times y squared is 5y squared. 5 times negative y is negative 5y. And 5 times negative 12 is negative 60. Okay, so let's simplify each side of the equal side down. And so on the left-hand side, let's group our like terms together. So I see we have a 2y squared plus a 3y squared, which is a 5y squared. And then for terms with just a y, I have a positive plus 4y plus a 27y. So that would give me plus a 31y. I have a negative 48 plus a 54. So 54 minus 48, that's a positive 6, so plus 6. Nothing simplifies on the other side of the equal sign because they're not like terms. So just rewrite it, 5y squared minus 5y minus 60. So first thing I notice, it's quadratic, and I go about solving quadratics differently, but then I notice when I try to get everything to one side, my 5y squares are going to cancel. And so it's technically really a linear equation. And so linear equations, we want to get variables to one side and constants to the other. So maybe we could just add 5y right now to both sides of the equal sign to get the y to the right-hand side, or left hand, that's left hand, and subtract 6 on both sides to get the constant to the right. So a 31y plus a 5y, that's a 36y, is equal to a negative 60 minus a 6 is a negative 66. So we're almost there. Get y by itself, divide both sides by 36. Okay, so I notice both of these are divisible. The numerator, denominator are divisible by 6. So let's just simplify this. 6 goes into 66 11 times. So we get negative, and then 11 over 6 goes into 36 6 times. Okay, so that was not a number that we said that y could not be. And as long as I did all my math right, I didn't make any arithmetic errors, that should be our solution. And usually if I make a little arithmetic error, someone in the class usually catches it. I'm looking for chats. Any questions on that? Good. So why don't you guys, it's your turn to try it. Okay, so, and I can zoom this in a little more if you want it bigger. But you guys are gonna take a moment and you're gonna try the following example and see what you get. So you have first a fraction 5 all over 5z minus 11. And then after that fraction, you have a plus sign and another fraction, and that fraction is 4 all over 2z minus 3. And then that is all equal to -3 all over 5 minus z. So I'm going to give you a few minutes, try it, and then once you get it, maybe put in the chat that you got it. And then we'll talk about it. So I'm going to just pause the recording while you guys are trying that. Okay, so this was kind of a good way for me to see where you guys are and how you're doing, and hopefully we can go through and clarify where you went wrong or where you were getting stuck. It's great for you guys to be able to try problems while we're going through the lecture. As I'm going through problems in the lecture, if you're understanding it and you know how to do the problem or you think you know how to do it, if I were you, I'd be working through it as I'm kind of working through it. You might be faster than me because I'm trying to explain things, but then if you get stuck, you can kind of come back and look at it. And then this gives you a time to actually try it and see, you know, where you might be struggling. And then it's better to see where you're struggling now versus when you're by yourself trying to do your homework. And so first thing that you guys should have done, looking at this problem, you have variables in the denominator, so you should have made it some restrictions. And so we can't have 5z minus 11. This cannot equal 0. And so if you add 11 to both sides and divide by 5, we get z cannot be 11/5. Same thing I hear, 2z minus 3 can't be 0. If I add 3 to both sides, divide by 2, I get z cannot be 3/2. And then 5 minus z, this cannot be 0. So z can't be 5. Okay, so those are our restrictions and our LCD. Well, none of these are have factors in there. And so our LCD is going to be the 5z minus 11 all times 2z minus 3 all times 5 minus z. So I'm going to kind of do shorthand here, just saying that I'm multiplying both sides by my LCD. Notice that when we distribute our LCD to this first fraction, it's the 5z minus 11 that's canceled. And so technically we just still have this 5 here, all times the two pieces that were not in the denominator. So 2z minus 3, all times 5 minus z, plus, so when we distribute the LCD to the second fraction on the left-hand side, it's the 2z minus 3 that cancels, and so we're left with a 4 that was in the numerator, and the other two pieces that weren't the 2z minus 3 in the LCD. So the 5z minus 11 and 5 minus z. This is equal to our numerator -3, and then on this side of the equal sign, the 5 minus z cancels, and you're left with 2z minus 3 and and 5z minus 11. Okay, so we got to do some distributing and simplifying on both sides. So let me just distribute the 2z times the 5. This is 10z. 2z times a negative z. This is a negative 2z squared. A negative 3 times 5, so this is minus 15. And a negative 3 times a negative z is a plus 3z. So plus 4. So let's now distribute here. So 5z times 5, that's 25z. 5z times negative z, that's negative 5z squared. Negative 11 times 5, that's negative 55. And negative 11 times negative z, that's plus 11z. Equals negative 3. And then distribute those two binomials. And so parentheses, we have 2z times 5z is 10z squared. 2z times negative 11, this is negative 22z. Negative 3 times 5z is negative 15z. And negative 3 times negative 11 is positive 33. So we can either simplify inside this parentheses first by combining like terms on each of those groupings, or we can just distribute and then combine like terms after. It's really up to you. Let's just kind of look at it here. If I have a 10z and a 3z, technically when we distribute, this will be a 13z, just so I know. So when I distribute this 5 times 10z, this is 50z. This 5 times a negative 2z squared. Wait a minute, I didn't do that right. I should have done 5 times 13. Maybe let's just distribute. Let's just go in there and distribute it. Okay. So 5 times 10 is 50z. Thought I could erase it. 5 times negative 2z squared is negative 10z squared. 5 times negative 15, that's a negative 75. 5 times 3z is 15z. So now distribute the 4. So 4 times 25z, that's plus 100z. 4 times negative 5z squared, that's negative 20z squared. 4 times 55, I can see where this took you a while. 5 times 4 is 20, carry my 2. 5 times 4 is 20, plus 2 is 22. So that's 220. Plus 4 times 11z is plus 44z. Now distribute negative 3. Negative 3 times 10z squared is negative 30z squared. Negative 3 times negative 22z is plus 66z. Negative 3 times negative 15z, that's plus 45z. And negative 3 times 33 is negative 99. Okay, left-hand side, combine like terms. Looking at all the terms with z squared, we got a negative 10z squared and a negative 20z squared. So this is a negative 30z squared. So just combining terms with z, I have a 50z plus a 15z, so that's 65z. 65z plus 100z, that's 165z. And 165z plus 44z is 199z. Did I just do that? What did I just say? 165 plus 44. Nope, that's 209. Trying to do things in my head sometimes. I just need to write it out. 209z. Okay, and then constants. Negative 75 and a negative 220, both negatives. So add them, we get negative 295 equals negative 30z squared, 66z plus 45z. It's going to be plus. If I add, that's 11. Carry, that's going to be 11. So 111z minus 99. So it looks like it's quadratic, but if we add 30z squared on both sides, those go away. Let's subtract 111z. And yeah, let's get the constant on the other side. So let's add 295. Okay, so what do we get? 9 minus 1, that's 8. I need to borrow, so that's going to give me 98z is equal to, this is a positive and a negative, so 295 minus 99. Which is 96. Yuck. Did anyone get this answer? Let's divide both sides by 98. And so z is equal to, I see that they're both at least divisible by 2.
Wait, isn't 295 minus 99 196?
It's supposed to be 196, I think.
Ah, 196. Yeah. Thank you. You're right. Does that go in there evenly? Twice? No? Yes. Yay. That little simple error at the end, it might have taken me a while to go back and find that. Okay. So z is equal to 2. So did some of you go back and actually try plugging that in to see that that was a solution? You know, some of you were saying you were checking your work. Okay, so not too bad. It's just a little tedious and just a lot of, you know, distributing and for one particular variable given more than one variable in the equation. So for example, you might have 1 over capital R equals 1 over R sub 1. So it has a little capital R with a subscript 1 plus 1 over R sub 2. And we want to solve for R here. So when you're solving equations for a particular variable and there's multiple variables, you're going to pretty much just go and approach this the same way you would do for getting the variable x by itself if it was just x in there. And so if you notice this, we have a fraction and we want to clear our fraction. And so looking at this, we want to find our LCD. And these are all representing, could be representing different values. So we have R times R sub 1 times R sub 2. So we're going to multiply both sides of our equation by this R sub 1, R sub 2. So the whole point to do that was so that our fractions would go away. Well, capital R, R sub 1, R sub 2, all over R. The R's are going to cancel. I'm just going to mute you guys all, and if you have a question, just let me know. Of course, that took away the screen. Okay, so R's go away. On this side, you're left with R sub 1, R sub 2 is equal to, well, when we distribute this to the first fraction, the R sub 1 is going to cancel, and you're left with R sub 2. Plus, and when we distribute this to the second fraction in that parentheses, the R sub 2 cancels, and you're left with just the R sub 1. Well, we want to solve for R. And notice that both of these terms on the right-hand side have R in it, but they're not like terms. And we want to get that capital R by itself. So the trick is, if there's more than one term with a variable that you want, get all those terms with that variable you're trying to get by itself to one side of the equation, and then factor it out. And so if we factor out this capital R here from the right-hand side, you'd be left with capital R all times the quantity R sub 2 plus R sub 1. And this was equal to R sub 1, R sub 2. And so now we can see we can get that capital R by itself by just dividing both sides by that parentheses, R sub 2 plus R sub 1. And so we've solved for capital R. Capital R is equal to R sub 1 times R sub 2 all over the denominator is R sub 2 plus R sub 1. Okay, we cannot simplify that because this is not strictly multiplication down on the bottom. And so we can't cancel out those factors in the numerator and denominator. Okay, let me let you guys have a chance and try one real quick. Let's see. So in this example, you're going to try to solve for little r. And so the equation is capital S is equal to little a all over the quantity 1 minus little r. And you're solving for little r. So I'm just going to pause the video real quick while you guys are working on that. Okay, so we're going to just walk through this example that you just tried. Hopefully you got the right answer. Again, you have a rational equation, and so you want to clear the fraction, figure out what the LCD is, and the LCD is just what this denominator is, which is 1 minus r. So if we multiply both sides of our equation by 1 minus r, we have S is times 1 minus r is equal to a all over 1 minus r. So 1 minus r's cancel. We want to distribute the capital S to that parentheses 1 minus r. And so we get S times 1 is S minus S times r, or SR, is equal to just little a. So there's only one term with a variable we want. And so if we subtract S on both sides, we get negative SR is equal to a minus capital S. And get r by itself, we can divide both sides by negative S. And so r is equal to a minus S all over S, negative S. So there's alternative forms of this that are the equivalent. If you have a negative in the denominator, this is the same thing as pulling the negative out front. So this could be the same thing as negative and then a minus S all over S. We can think of this if we wanted to as distributing this negative. So this is equivalent to positive S, just rewriting my order, minus A all over capital S. Some of you might have written this as two fractions. We can break this down as S over S all over minus A over S, which is equivalent to 1 minus A over S. So there's so many different forms. So if you've got one, hopefully it was one of these. And they're all equivalent. You guys good? Maybe I should clear that before you say anything.
I have a question.
Yeah, Kiara?
If you're distributing the negative, wouldn't it be a plus S?
Yeah, so right here, if on this piece, on the top up here, when I distributed the negative, this gave me the negative A. So right here, this is R is equal to negative A, and this would have been a plus S all over capital S. And I just rewrote the order here. Is that what you were talking about?
Yes.
Okay.
Thank you.
You're welcome. Okay, so we're almost done with this section. I just wanted to go over one application problem. There are a couple applications in your homework. Let's see if I can pull. Okay, so counting calories. Now I'm going to feel bad because I don't even know how to pronounce this name in here. So is it Taishira? She tracks her net calories. Those are calories taken in minus calories burned as part of her fitness program. For one particular day, her net intake was 1,480 calories. Her lunch calories were half the breakfast calories, and her dinner calories were 200 more than the breakfast calories. She ate 120 less calories in snacks than for breakfast, and she burned 700 calories by exercising on her elliptical. So how many calories did she take in from snacks? So always applications, just read through it. You can get kind of overwhelmed with all the information, but just read through it at least once and then go through and kind of pick out information that you know. I noticed as we read through this, different meals were dependent on what she had for breakfast. And so that right there clues me on maybe that should be what my variable should represent. And so let X equal the number of calories she had for breakfast. So you always want to define what your variable is representing. And then we're going to go through here. We're going to have enough information to have some equations or to find some equations. So for one particular day, her net intake was 1,480 calories. Okay, so she took in 1,480 calories. And we'll come back to that in a minute. Lunch calories, that was half of her breakfast calories. So I know for lunch, this is going to equal 1/2 times the calories that she had up here for breakfast. And then it says, and her dinner, this dinner calorie was 200 more than her breakfast calories. For breakfast, which was X, plus this 200 calories more. And then she has a snack. She ate 120 less calories in a snack than for breakfast. So her snack, we can say, well, this is what she had for breakfast, which was X, minus, it's 120 less, so minus 120. And then she's going to burn some calories so she can take that off of her net. And so she's burnt. So this would actually mean that we can subtract off that number of calories. So negative 700 calories. Okay, so we know all together that her intake was 1,480 calories. So let's set up an equation with that. So we have 1,480 calories. This is equal to the calories she had for breakfast, which was X, plus the calories that she had for dinner, plus the calories she had for a snack, so plus X minus 120. So that was, breakfast, lunch. I forgot lunch. So that's breakfast, dinner, snack. Let's do lunch in there. So plus lunch, which is 1/2 X. And then minus 700 calories. Okay, so here's the equation that will help us solve this. This will help us solve for X, which we have to be careful because really it's not asking us how many calories she had for breakfast. We have to go back and figure out how many calories she took in for her snack. Okay, so let's just solve for X first. And so linear equation, let's simplify down the right-hand side of this equation by combining like terms. We have an X plus an X plus an X plus 1/2 X. So a couple things here. I can go ahead and just clear all my fractions now, or I can add these. If I add these, I need a common denominator. And so I can think of this as 2 over 2x, 2 over 2x, same thing as 1x. So this would give me 2, adding my numerators, keeping my denominator the same. 2 plus 2 is 4 plus 1, so that's 5x all over 2. And now let's add our constants. And so our constants, what do we have? We have a 200
Wouldn't it be
minus a
7x
120.
because of the snack?
Is there a question?
Yeah, wouldn't it be the 7x over 2 because the snack is the other x minus 120?
Oh yeah, thank you. I missed that X in here. So I underlined it, but I didn't get a common denominator. So you're right, thank you. 7x over 2. Okay, so 2x plus 2x is 4x plus 2x is 6x plus another 1x is 7x. And so now we have 200 minus 120, which is 80, and 80 minus 700. So that would be negative 620. Okay, so let's get the term with a variable by itself. Let's add 620 to both sides. And so we have a less than 68 equals 7/2 x. So if you have a fraction in front of your variable and you're trying to get rid of that coefficient in front of the variable, it's easier, I think, to multiply by the reciprocal instead of dividing by that fraction, because there's just one extra step that you're going to have to invert multiply. And so let's just think of this as multiplying both sides by 2/7. Do something to one side of the equal sign, we have to do it to the other.
I have a question.
Yeah.
How did you get the 148 from 1480?
Oops. Gosh. I dropped my 0. And so that's going to change that, huh? let me change that. Thank you. So 0 plus 0 is 0. 8 plus 2 is 10. Carry that. That's going to give me 11. That's even a much nicer number. So I got 2,100 on the other side when I added that, which 7 goes into evenly, which is nice. So 7 goes into 21 3 times. And so we'll have 2 times 300 is equal to, well, the whole point of doing this was so that we would have a coefficient of just x in the numerator. And so we get x equals 600 calories. But this was for breakfast. And the question, though, wanted us to know how many calories did she have for her snack? So we need to go back up here and plug in that 600 for x. So for her snack is equal to 600 minus 120 calories, which is 480 calories. Okay, so there was 480 calories consumed for a snack. Thank you, guys. Errors I made in there. So just like, you know, when we get to the answer, something might would have a negative number, and I would know that, you know, that didn't make sense, or so. Okay, so I don't know how long I lost you for, because it just like all you guys just disappeared, and then it's like, oh, I just lost internet or something. But then you came back on. So, and then it said that the meeting was being recorded. So hopefully you caught everything from what I was saying about the problem and the answer. How about a break? You guys ready to go get some blood flowing and maybe a cup of coffee or a snack? 480 calories worth. Okay, so let's take a break. Yay, Kiara. And let's meet back here at 9:10. So I'm just gonna pause the recording, and I'll see you guys in a little less than 15 minutes. I think I'll record.